Good morning. Today we again continues to solve the paper 1 from round 1 2017 of British Physics Olympiad. Today we will solve tasks C and D, like C and D. So let's start. A particle moves in straight line with initial acceleration 10 meters per second to minus 2. The acceleration decreases uniformly with time until after 10 seconds the acceleration is 5 meters per second square, and from then acceleration remains constant. Initial velocity is 100 meters per second. So let's write down all variables. So we have speed initial is 100 meters per second. Initial acceleration initial is 10 meters per second square. Acceleration final is 5 meters per second square, and we have that also we have a rate of change of acceleration. We can write down like delta A over delta T is equal to, in this case it's even cubed. It's quite interesting that it changes, we don't know, but we actually can find out because we have time, it's 10 seconds, and rate of change is 10 minus 5 over 10. It's equal to 0.5 meters per second cubed. And also, first task is to find when velocity is doubled. So we can also write down like velocity final is 100 multiplied 2, it's 200 meters per second. So what now? Actually, it would be quite tricky, but we have a fact that we have initial acceleration, final acceleration, and it changes uniformly, so we can use a formula of average. So acceleration average is equal to 10 plus 5 over 2. It's 7.5 meters per second square. So we can find and change during period of 10 seconds when acceleration changes. It's delta V1 is 7.5 multiplied 10. It's equal to 75 meters per second. So as we see, 75 plus 100 is still less, so we now know that after 10 seconds speed is still not 200. So after we see that constant acceleration now is 5, so to find time is equal to time 1 is 10 seconds plus 200 minus 175 because it's 100 plus 175 over 5 because it's our acceleration, we get that 10 seconds plus 25 over 5 is 5 seconds, so we have 15 seconds. It's time for each the velocity doubles. So now it's more interesting. Second one, we will draw graph of velocity against time. So we have pen, we draw axis y is velocity meters per second, and axis x it's time. So there are actually two periods. First period, a period of acceleration, like change of acceleration. A second one, it's a period of constant acceleration. I will draw three speeds, critical speeds. First one is 100, it's initial speed. Second one, it's 171, it's time when change of acceleration is over. And first one is 200, just for simplicity. First of all, we know that it's 0, so we have our speed is 0. When time is 0, our speed is 100 meters per second. Second one, after 10 seconds, our speed is 175. And we draw like this, decreasing gradient is decreasing, because as you see, acceleration is decreasing, so a gradient is decreasing. And now, it's maybe the most important. We continue our graph, it's linear, now it's linear because acceleration is constant. It's positive gradient but still linear, and it should be no like this change between this and this, because final acceleration is the same like constant acceleration. So it should be no any like change of graph. It shouldn't be like this or like this. It should be like smoothly. So we get it. Of course, we would need more details like to mark it, but you see I don't have a grid to draw it more accurately, but still it will work. So let's do our next task. It's D. It's actually quite classical. Everyone in school did it. It's Suvat. Now we have to express, we have to find a distance A in terms of velocity, angle alpha, and gravitational field strength G. So what we have, so understanding a distance A from vertical work kicks a ball like with velocity v and angle alpha to horizontal, the plane perpendicular to that wall. It kicks the ball. Its coefficient restitution, actually it's more like it includes a speed before and after, but two objects, but because we have only one object, in this case it's ball, it's simplified formula that it's speed after over speed before. It can't be more than one because it would contradict a law of energy conservation. So max, if collision is absolutely elastic, speed after would be the same as speed before, so coefficient would be 1. But in this case, we have that it's equal to 2/3. So let's go. Let's draw our ball object. We have object ball here. It has speed that goes here and angle alpha. Distance between ball and this is A. It's like, because gravitational force acts on it, it's like ballistic trajectory, and after it rebounds, it's go back, and it falls on distance to alpha, or to A. So let's draw. First of all, we know that that coefficient restitution influence only horizontal speed, because speed has two components, Vx and Vy. So Vx1 is speed before rebounds is equal to V cosine alpha. Vy is equal to V sine alpha minus gt, because gravitational constant over time. So Vx2 is equal to the same speed horizontal, because there are no forces except this rebounding one, but there are no forces that influence the speed. It's equal to E over V cosine alpha. E is less than 1, so speed will be less. But still, and Vy1 is still the same, because no coefficient of restitution doesn't influence it, so it's the same. V sine alpha minus gt. So what now? Now we can go through a few ways. First of all, one of them, we know that alpha, like A, is equal to time 1. It's like time that ball needs to go from point A to the wall. Is equal to time 1 multiply by x1 is equal to time 1 multiply v cosine alpha. And second time is time 2, and we have 2 alpha, because this time a ball goes distance to A for period of time t2. So 2A is equal to t2 multiply its new speed that is less. It's v cosine alpha. V cosine alpha. So now we can find a ratio like between times. We have that t1 v cosine alpha is equal to 1/2 of t2 e v cosine alpha. We can delete it, and we have that e is equal to 2/3, so t1 is equal to 1/2 multiply 2/3 t2. t1 is equal to delete 1/3 t2. So t2 is equal to 3t1. So we have time. So total time is equal to 4t1. But what is more interesting, we can now use expression for, we now go to our vertical speed. Because total time is defined by ball is falling, because there are no any horizontal forces, so if not like gravitational, this ball would like move infinitely long, but because it is gravitational force, eventually ball will fall on the ground, so speed 0. As we see, well, a high like this high y, it would not increase because it's like conservation of energy, potential energy in our case. So we can say the total period, like total time, is equal to, we can use like from another Suvat problems, we know that like ball falls without air resistance, ball falls like arc. So total time is 2 over v sine alpha over g. It's our total time. Now it's simple. We now just make it equal. So 2v sine alpha over g. So what we have, t1 is 1 is a over v cosine alpha, it's horizontal speed, plus 2a over e v cosine alpha. Now it's simple algebra. We multiply both sides on v cosine alpha, so we have 2v square sine alpha cosine alpha over g is equal to a plus 2a over e. We have that 2v square sine alpha cosine alpha over g is equal to, we can take a out of brackets, a 1 plus 2 over e, that is equal to a 1 plus 2 first over multiplies cancel, and we have for a. So we found out that a is equal to 2v square sine alpha cosine alpha over 4g. And that's it. It's our expression.